Greetings, my fellow descendants. It's your boy right JK Pro, and I'm back with a brand new tutorial. Very interesting topic today. We will be dealing with the Doppler effect. In this tutorial, I will be mainly explaining the Doppler equation and eradicating all these misconceptions learners have about the Doppler equation and Doppler effect as a whole, and actually giving you a brief explanation of what Doppler effect is. I won't be defining a Doppler effect exactly as it is, okay, guys? According to the exam guideline, because that's what actually confuses a lot of people. But what I will be doing is I will be actually dissecting it and making it much more easier for you to understand what the Doppler effect is. So you'll have to bear with me, because if you want those good marks, you'll have to pay attention to the whole video. And I believe at the end of this video, everyone will be able to achieve at least an 80% when dealing with the Doppler effect. Okay, guys? So guys, I'm going to be making practical examples of daily living, because I believe that physics is all about our daily lives, and that's what teachers fail to do in class. All right, guys? Physics is about what we do each and every day. It's nothing complicated. So the Doppler effect is the same thing. So now allow me to write down Doppler effect, right, so that we can begin. And I prefer using a red pen when teaching physics, right? Right. So now we are going to be dealing with the Doppler effect, right? And everything related to that, right? Doppler effect. My handwriting is so poor nowadays. I don't know what happened. Right. What is Doppler effect, guys? You can go to your examination guidelines and try and get those definitions. Okay, guys? It's very wise to do so. But in most cases, the definitions have bombastic words that learners don't understand. And if you can't define something, there's no way you're going to understand it, right? So what I'm going to do is that I am going to make a practical example that's going to make you understand this term called Doppler effect. But however, when you write your paper, whichever day you are writing your physics paper, go to your exam guideline and remember that particular definition as it is, so that you get your marks. What I'm doing here is just pure dissection, as I always do. I'm just dissecting it so that you can understand it, not for you to define it when given in a paper. Right, guys? Right, so let's make an example. So this boy is a rapper. During break, he's rapping, spitting bars, right? Yeah, he's a rapper. And he's very loud. And he's rapping, right? Please take out your book and your pen and make sure that you copy everything that I'm doing, okay, guys? So that you can understand, right? If you're not good with taking down notes, make sure that you listen attentively, okay? So this boy is a rapper at your school, and he's rapping. And when now you are busy there eating your lunch during break, ne? And now you can hear, man, I know someone is rapping here. Your ear is detecting something, that there's someone who's rapping, right? Your ear, you are listening. It's listening to this person rapping. Okay, guys. Now, as he's rapping, you are listening. Now, how is this related to Doppler effect, guys? Remember, this is the example, guys. You will never be questioned on a rapper and a listener and stuff. This is me trying to make everything easier, because most of you guys are into these things. Okay, guys, how is this related to the Doppler effect? What Doppler effect is telling us is that the amount of sound, right? The amount of sound, right, that this guy is taking out, is not the same amount of sound that this girl is going to listen to. I hope you understand what I'm saying. Let's just say the frequency of this sound is maybe 50 kHz, right? When it reaches you, let's just say there's a 5-meter distance. When it reaches you during break, it will reach you as maybe 25 kHz, right? Why? Because of the distance, guys. the distance. You are far away. Let's make an example of you. Maybe you live next to a tavern. Maybe there's a tavern next door, right? Do you agree with me that the amount of sound that you hear when you are in your house from that tavern, right, is not the same amount of sound that the speakers are emitting at that particular tavern? It's different, because if your friend was standing next to this rapper, right, she was going to detect more sound, maybe 45 kHz frequency, right? But because now when you are here, you are further away, depending on the distance, you are going to hear less of it. You can detect it, but you can't hear fully. Do you understand what I'm saying? So Doppler effect is basically telling us that the frequency between this person who's taking out the sound and this person who's listening to the sound is not the same. The frequency that he's taking out when he's rapping and the frequency that your ear is receiving is not the same. It can come out here as 50, but it will reach you as 25. It is not the same, right? I hope it makes perfect sense. However, this is just a sketch of what is happening in Doppler effect, because now Doppler effect deals with cars and everything like that. Okay, guys? But once you understand this whole ideology that I just gave to you right now, you will never go wrong when it comes to your Doppler effect. You will never go wrong. This is basically the definition of Doppler effect, okay? Not the Doppler equation, but the Doppler effect. Okay, guys? So now that you understand this, I'll have to go deeper now. Alright, please bear with me. Stay glued to the screen and understand what is happening. Now, guys, there is an equation that you will find at the back of your question paper. It's like this. Right. Okay. In this equation, V stands for the velocity. Always in physics, V stands for the velocity. Your F stands for the frequency. I need you to note this down, because this is usually 3 marks. They usually ask this question that I'm going to try and do right now. This is your wavelength. This is your wavelength. Right, guys? Now, what is happening here? What do we use this thing for? It is used for anything related to the Doppler effect. So I'm going to give you an example. They might say to you, they might give you a velocity of 5 ms1, a velocity of a car or something, and they might give you a wavelength of 5 meters, right? And they tell you that please find the frequency, right? Well, now what are you going to do? You are going to plot all these things and substitute them in this formula. Do we have the velocity? Yes, we have the velocity, and it's 5, right? We are looking for the frequency. Do we have our lambda? Lambda, it means wavelength, guys, okay? I'm going to explain briefly the relationship between the frequency and the wavelength. So what is the lambda there? It's 5. You did this in grade 10. So how are we going to find F? We divide both sides by 5. 5. There we go. 5 divided by 5, it's 1. And your frequency is just like that. KZ. And that's your frequency. Right? So that's what they usually ask for. And it's important to get this correct, because it's usually the first question of the Doppler, or the second question of the Doppler effect, okay? Sometimes they might say find velocity, okay? Sometimes they might say find lambda, right? This is just basically you knowing how to manipulate your mathematical equations to make something the subject of the formula. It's not complicated at all, okay, guys? So pay attention to this, okay? Right. This is not complicated at all. Now, there's something that a lot of grade 12 learners make a mistake when doing. So sometimes when you're doing Doppler effect, they will give you time. Maybe they might say a certain car is moving at this. It took maybe 5 minutes or 10 minutes to reach a point. Or sometimes they might say 60 seconds. They give you time. Okay, guys. Immediately when they talk about time, when you're dealing with your Doppler effect, right? Once you see time in the question, right, and they ask you to find the frequency, right, you are going to go to your original look, né? You are going to go to your original equation that I just showed you right now, right? So let's see, V F lambda. Is there any way I can find the frequency using this time here? No. Why? Where am I going to put time? Because yeah, they need a wavelength, they need velocity. So what am I going to do? Worry less. There is a formula now which says T equals to 1 over F. You can find this formula in your grade 10 books, right? So what are we going to do with this formula is that now when you have time, you can find frequency. How do you find frequency, guys? You just say 60 seconds is equals to 1 over F, right? We cross multiply because this is the same as 1. We cross multiply and we have 60 F, which is equals to cross multiply 1 times 1, 1, right? And divide this by 60 on both sides, and your frequency will be 1 over 60, right? Press that in your calculator, and whatever you get, you'll put your units. Okay, guys, right? So I think a lot of people get confused here, but you will find this formula in your formula sheet, right? Information sheet as well. You use this if you are given time. You can always find the frequency. Okay, guys, if you are given time, you can always find the frequency using this. Don't be confused and start trying to plot things that don't exist here. You only use this if you have the wavelength and the velocity, or you have one of these or both of these, 2 or 3 of any of these. Okay, guys, so this is what I wanted to outline before I can go deeper into the Doppler effect equation. Okay, guys, all right, bear with me. I hope you're noting down everything I'm saying. Do not cram, guys. You can't cram physics. You must understand it. It's life. Physics is life. Okay, guys, now I'm going to teach you guys the Doppler effect equation. Now, when we're dealing with the Doppler effect equation, this is what's going to happen now. This is where a lot of learners lose marks. It's usually out of 5 marks. So I'm going to simplify it for you. Let me write down equation. Okay, guys. Okay, guys. Now, a lot of people will want to know, what is the Doppler effect equation? How do you get it? And all those things. Okay, guys. Not a problem. I'm going to look for it somewhere here in my documents. Okay, guys, let's go back here. Our Doppler effect equation. I don't want to make mistakes. Doppler effect equation. Before we can go into that equation, guys, there's something I have to show you, right? There's a story that I invented a year ago, okay, to make me understand the Doppler equation better, right? Cool, guys. So now please pay attention. Now I need you to be very attentive. You are a girl. Even boys, please imagine as if you are a girl or something. You are a girl. This is you. Let me try and draw her there and there. I'm not really a good artist, but yeah. So you are a girl, and it's after school, and you are a grade 12 learner, I believe, so this is not going to be hard for you to understand. And now there we go. There comes a boy. He approaches you, and you end up hugging this boy. Okay, you guys are hugging, right? While you guys are hugging, your neighbor, your mother's friend spots you. She sees you guys, right? She sees you guys. She spots you guys, and she's like, "Oh!" And this is your mother's best friend. So chances are she's going to tell your mother that you are dating. And remember, your mother said, if I can see you with a boy, or ever I hear that you're with a boy, I am going to kill you. I am going to discipline you. Okay? So that's what happens, guys. She sees you, and now it's after school. The boy goes home. The neighbor went home as well. to tell your mother about all these things that you've been doing. And now you have to walk home, right? This is your way home. I'm trying to create a pathway, right? And now this is where you live, right? Okay, guys. Now, the distance from the school. Let's just imagine that this is the school, right? This is the school. This is the school. Now, guys, the distance from this girl, where she's standing at the school, to her home is 8 meters. Okay, guys, let's imagine that. Remember, physics is an imaginative subject. You must bring things to life. Okay, guys. Now, what happens is now she has to walk back home, right? Now she's walking. And when she curves, she can spot her mother. Her mother is down there next to the gate with a belt, waiting for her outside the gate. Yeah? She wants to discipline her for what? For hugging a boy. Do you understand what I'm saying? So, what will happen to you? Please put yourself in the shoes of this girl. What would happen to you internally? Right? This is what's going to happen if you're a normal human being. If you're a normal human being, your heartbeat is going to increase. Yeah? So the girl's heartbeat increases, goes up. Why does it increase, guys? She's nervous. She is scared, right? So the heartbeat increases. But as the heartbeat is increasing, can you see? The more closer she gets, the heartbeat is increasing because she thinks she's going to be murdered today, you know. She's going to be disciplined today. So as she's approaching, the heartbeat is increasing. But now what is decreasing in this whole scenario? The distance is decreasing. Please take note of this. The distance is decreasing, right? As the heartbeat is increasing, the distance is decreasing. Right, just look at this. She was here, right? Her heartbeat was not beating that fast. But as she's approaching her house, her mother's gate, her heartbeat is increasing. Why? Because the mother is there and she's waiting for her to come home. Do you understand? And what is decreasing now is that now she's no longer at the school, guys. As she's walking, the meters are decreasing. It's no longer going to be 8 meters. It might be 4 meters, 3 meters, 2 meters, 1 meter. So the distance is decreasing. Now, what is my point here, guys? If you've been attentive while I'm making this example, what is distance according to science? According to science, we can view distance as the wavelength. Makes sense now why I made this example, right? And what is our heartbeat, guys? Our heartbeat can be considered a frequency. Guys, now I hope it brings everything to light, right? So, yeah, our heartbeat is the frequency and the distance is the wavelength. You know very well that the wavelength is the distance, guys, right? It's the distance. Length has something to do with distance, right? So, what am I saying to you? I'm saying when the heartbeat increases, in other words, when the frequency increases, what will happen to the wavelength? The wavelength, which is our lambda. Oh my God. Sorry for that. My fellow descendants, I'm sorry for that. So what would happen is now my oh God, what just happened? What would happen is now my lambda, which is my lambda, would decrease. Okay, guys? So hence I made the example of the heartbeat. Okay, guys? The heartbeat and the distance. That when the distance decreases, the heartbeat increases because you see danger. Right? So this makes a perfect example. And once you understand this, guys, once you understand what is happening, sorry about that. Once you understand what is happening here, you will never go wrong when it comes to the Doppler effect. Once you understand this, You will never go wrong when it comes to the Doppler effect. This is a relationship, guys. It's a relationship between the wavelength and the frequency, guys. Okay, guys, what is that relationship? Let's pin it down. This is a relationship, and it's a very important relationship that you have to understand, right? It's a relationship. Okay. The relationship is, guys, when the frequency increases, our lambda decreases, right? There is proportionality involved now, okay? When this one increases, which means the other one will also decrease, right? So there is a relationship between this. So guys, let's prove if my example was actually correct and really the frequency will increase when the lambda decreases. Let's prove my theory, okay? Let's prove this theory of mine that frequency increases as the lambda decreases, or the heartbeat increases and the distance decreases. Let's prove this thing, guys, right? So I'm gonna prove it for you guys, and I'm just gonna show you how it's done. Okay, guys, I'm gonna prove it for you. So let's see. Guys, remember this equation that I showed you earlier on? I'm going to use that equation to prove my theory, right? So now I'm going to make the frequency my subject of the formula, right? Why? I want to show you the relationship between the lambda and the frequency. So how do I make frequency the subject of the formula? I divide by whatever is next to the frequency, which is our lambda, and I divide by lambda on both sides, because according to maths, what I do on the right, I must do on the left, right? So these will cancel each other because there's multiplication in between, right? And what do I have now? My frequency is V over lambda, right? What is happening now? Can you see that when my frequency is increasing, my lambda is decreasing? So which means my theory was actually correct, that the relationship between these two is that when one increases, the other decreases, right? Now that I've proven my theory using that example of a hug and your parents wanting to beat you up, now we can move into the actual Doppler equation and try to see how can we manipulate this thing and understand it better. Okay, guys? So we're going to move into that and understand what is happening. So I just have to erase everything here. Okay, guys. All right. So 13. All right. Right, guys. Sorry for the inconvenience. All right. I'm gonna use red again, my favorite. Okay, guys. Now I'm going to do the actual Doppler equation, right? The actual Doppler equation given as D. I should decrease the size of this first. I don't know why it's not decreased. Which is my D. And my D would say Doppler equation. Okay, guys, this thing is still fat in a way. I'm sorry to say that, but it's still fat, but it's fine. It's still fat, so I'll just decrease. Yeah, now it's back to normal. Okay, guys, now we're doing the Doppler equation. Now the Doppler equation requires you to be disciplined and very focused and listen attentively. Right, guys. I know a lot of grade 12 learners do not like longer tutorials, but longer tutorials are actually beneficial in the long term, especially when you're dealing with the preliminary exams and your final exams. So pay attention. This is what's going to happen now. I told you about the relationship between the frequency and the wavelength, right? Now you know what's happening, right? Now, guys, I'll have to come and bring the Doppler effect into life, right? Now I am going to use cars. Now, listen to me. what I'm going to be doing with cars is very much similar to what I was doing with a human being who's going to be beaten up, okay? It's the same thing, but now it's more standard, okay? It's more Doppler. That's what I used to say. It's more topic based, okay? So let's look at it this way. We have a car, right, which is emitting, it has a siren there, right? It has a siren, right? Let me write this down for some of you guys. It has a siren, right? And this car is moving in that direction, right? And it's moving at maybe 5 ms, and that's the velocity, okay? I'm making an example, guys. A lot of physicists will kill me for this, but it's fine. Now, as it's moving, when you are waiting for a bus, you are going to town and you're waiting for a bus. Now, note, this is the actual Doppler effect, guys. I am not making this up. If you can open a textbook, you'll find something similar to this, explaining Doppler effect in this way. However, how I started this tutorial, I simplified it with something that you are used to so that I can come to more complex examples of the actual Doppler. Right now, you know how the knowledge is, right? So when you are going to detect the siren with your ear, right? Okay, guys, so what is Doppler effect saying, right? What do we know? We know that frequency and the wavelength, they have a relationship. Let's just say the distance is 10 meters, right? What is the relationship between the frequency, right? Let's just say the frequency is 80 Hz, right? Now, what is the relationship between the frequency and the lambda? We know that if one increases, the other one decreases, okay? Am I right? Good. If one goes up, one goes down, right? Cool. So, let's see. In this particular thing, you can see that this car is approaching you. And when you are that stationary listener, right, you are standing in one place. Okay? You are standing in one place. Now this car is approaching and it's emitting a siren with 80 Hz frequency, whatever they call it, right? Now, you do agree with me that I taught you that whatever this thing is emitting, according to Doppler effect, you are not going to detect the same number. It's either you're going to detect half or anything less than, but it will not be the same, right? We spoke about that earlier. So now, it's coming, right? It's coming closer to you, right? Now that it's approaching, guys, this is what you have to know. Cram it if you have to. Ne? When a source, ne? We're going to do this now. When a source is moving towards, right? It's moving towards a listener, right? When a source, S stands for source, when a source is moving towards a listener, what happens to our frequency? Our frequency will increase, right? And our wavelength will decrease. That's number one, right? Does this look familiar? Yes. My previous example, I told you of you approaching your mother's gate, right? Do you remember? Because you were approaching your mother's gate, what was happening? Your distance was decreasing, and automatically once the distance starts decreasing, it means that now your frequency is obviously increasing, right? So anytime you see the source approaching the stationary listener, right, or once the listener is approaching a stationary source, right, just know that the frequency is increasing and the lambda is decreasing. Now, my point number 2 is when the source is moving away from the listener, so this is away from the listener, what is happening there? what is happening? The vice versa of what we did above, which means now the frequency will decrease and the lambda will increase. Cram this. I need you guys to cram this. Okay? Cram this, because I'm gonna go in deeper and dissect this. Okay, guys, so now we have a brief understanding of what is happening, right? As I told you, I don't like explaining things in halves, so that's why I'm doing a lot of examples so that you guys can understand, right? So now we have a clear vision that if a car is approaching you with a siren or a police car is approaching you, the frequency is increasing, right? But the distance between you and the car is decreasing. If it was at the robots and now it's next to you at your house, the wavelength is decreasing, right? Good. Now we are going to talk about something that is very important for you guys to understand the Doppler equation. Now that I've taught you all this, now it all comes down to one thing. Remember, the Doppler effect equation is worth 5 marks that you cannot lose. Actually, everyone can get 3 marks there because everything is much more easier there. It's all about plotting, I believe. All right, let me return this. Good. Now, guys, this is what's going to happen. Put this in order. Now we have what we call a frequency of the listener, and we have what we call the frequency of the source. Guys, what is the source, guys? Let's dissect this. A source is the one that is emitting. Right? I'm not sure if I'm using the right thing, because emission is all about spectrum, but it's fine. You understand. I can say releasing, right? Right? The sound. It's releasing this sound or this frequency. That's the source. Ne? So it's very good that it's very important or crucial that you identify the source and the listener, right? Because they can alternate sometimes, okay? So the frequency of the source is the frequency that particular car is emitting or releasing. I hope I make sense. The frequency of the listener is what I taught you. It's what you were, if you are listening to that rapper at your school, it's what you are detecting. It's what you are detecting. Okay, guys. Now that you are detecting, there is a relationship between these two things. Now I'm gonna go down and write them again. There's a relationship, right? There is a relationship, and once you understand this relationship, the Doppler equation is going to be much more easier. So what is the relationship, guys? The relationship is now the frequency of the listener and the frequency of the source, right? What are you going to do, Wena? The first thing you're going to do is that you're going to check out what I taught you previously just now. If the car is moving towards or it's moving away. Okay, guys? If the car is moving towards, automatically you know that the frequency is going up. If the car is moving away, you know automatically the frequency is decreasing, right? But whose frequency is decreasing? Now let's use our logic sense. Can the frequency that we are emitting as a source decrease? It's rare, ne? Why would it decrease? It's rare, okay? It's rare. Absolutely rare. Okay, guys. So when we're talking about the frequency here, we are talking about the frequency of the listener. Okay, guys. We are talking about the frequency of the listener. Okay, guys. So every time you predict what is happening here, just know that we are referring to the frequency of the listener. Okay, guys. Okay. So let's see how we're going to use this to plot in our Doppler equation. What is the relationship between this and this? So if they tell you that a car is moving in that direction, and when you're standing on the bench here and it's approaching you, you know automatically that the frequency that you're going to detect is going to be much more higher, right? Therefore, the frequency that you're detecting is positive. It's like that. Okay, I don't want to lose a lot of you because a lot of you might not understand what is happening and stuff. Okay, guys? So I don't want to lose a lot of you. Okay, guys? So let's see. Let's make it much more easier. Let's make it much more easier. Let's make it much more easier. Oh, that doesn't want to move. I don't know for what reason. Okay. Right. So, I'm saying to you guys, there is a relationship between the frequency of the source and the frequency of the listener. Okay. If a car, I'm going to draw two of them here so that you guys can cram them. Yeah. If a car is moving towards you and you are standing there on the bench, yeah, just know that this frequency of the listener is going to be positive. It will be greater than the frequency of the source. Okay. If you are standing there and the car is moving in that direction and when you are at the bench, just know that the frequency of the source will be greater. Guys, please cram this. I'm sorry to say this, but please cram this. Because this is your meal, your ticket to success. Okay, guys, please cram this. Okay. So what am I saying here is every time they say to you, immediately when they say to you, the car is moving towards something, the stationary listener, just immediately write this down and start doing this, right? The frequency of the listener will be greater than. Okay, guys? But once they say the car is moving away, just know that the frequency of the source is actually the one that is going to be greater. Okay, guys? I hope I am making sense. If you have any problems, please drop your questions in the comment section. And I'll explain everything further right there. Right. I hope I made sense. Now the question is, guys, how do I apply this knowledge into my Doppler equation? Perfect. I like those type of questions. Now, I'm going to create a scenario and I'm going to change this to a car. Here is a car. It's moving towards you. You are sitting there on the bench, right? Remember, you are a stationary source. Stationary listener, I mean. So you are the listener and this is the source, right? It's emitting a frequency of 50 Hz, and when now you are detecting a frequency of 25 Hz, and the velocity of this car is 85 ms1, and yeah, and then the speed of sound in the air, they're going to always give you this. Okay, guys, the speed of sound in the air, I don't know, I forgot, maybe it's probably 343, but it might be 340, right? Not important for now. They're gonna give you this. Okay, now they're telling you, maybe they will say to you, I don't know, let's just say find the velocity. Find the velocity of the listener. Okay, they're looking for the velocity of the listener. Now the question is, K-Pro, how are we going to apply everything you've taught us into this question? Okay, guys, easy peasy. The first thing you're gonna do, we are going to determine if the car is moving towards or away. So what is happening? This is the first step now. Okay, guys, I'm sorry about that. It's just zoom out. Okay, it zoomed out in the wrong direction. So the first step to this, guys, for you to be successful when doing your Doppler effect, guys, this is what's going to happen, guys. The first step, step number 1, is the car moving away? Is it moving towards or away? It's moving towards. So what do we know if a car is moving towards? What do we know about that? We know that the frequency of the listener, what must happen to the frequency of the listener? It must be greater than the frequency of the source, right? That's the first thing. It's very good as a physics learner to have analysis within you so that you can understand what is happening, right? Now, point number 2, the question is, how do we apply all these things that you taught us? We have already applied one of them there. Cool. Now the question is, how is all this gonna help me out? Good. Now we have our Doppler equation, guys. Okay, I'm not sure if I'm mistaken or what, but what do we usually say in our Doppler equation? I think it's like this. I am not sure. It's like this. Right. That's our Doppler equation right there. That's our famous Doppler equation, right? So now the question would be, how do you solve the mystery of the velocity of this? Guys, we already know what the velocity of this is, right? We know the velocity of this. But just to prove that the Doppler effect is in fact effective, I am going to look for the velocity here. As a science learner, you know what is the velocity here, right? But it's fine. We are going to dissect this, right? So now, this is the Doppler equation. So how does this first step help you? This first step is going to give you direction, right? So now, we know very well that the frequency of the listener here must be greater than the frequency of the source. And remember, in mathematics, this can also mean positive, right? Good. That means now the frequency of the listener must be positive. It must be greater than the frequency of the source, right, guys? Now, I want you to take a pen and say, this is my frequency of the listener here, right? That's the equation for the frequency of the listener. And I want you to take a pen and say, this is the frequency of my source. Ne? Don't separate them when you're calculating. I want you to separate for understanding purposes. All right. So whatever you're going to plot in this equation, it must be greater than the number that is here. What is the frequency of the source? I gave it to you there. The frequency of the source is 50. Hz. It must be in brackets, okay? When we're calculating Doppler, right? Now, here is where this thing comes in. Ne? These V's, guys, these V's actually represent the speed of sound in air, which is usually given, guys. It's always the same, right? If they say it's 340 speed of sound in the air, you're usually going to come here and just say, okay, let me write it down for you. 340. Oh my God, what did I just do? All right. It's my pen, I'm sorry. Just going to come down here and say 340 over 340, okay? It's always the same, guys. Do not worry about these two V's. You are always given the speed of sound in air. It's either 340 or 343, I'm not sure. Okay, you are always given this. Now, let's see what's happening now. Now, this is where a lot of learners get confused when doing the Doppler effect. Okay, guys. When we're doing this now, what's going to be important is now we're going to refer to our step 1, where we said T, it's coming towards us and the frequency of the listener is increasing. So what does that mean, guys? It means now that I am going to come here and say, what do I have to do to make my denominator and my numerator be bigger than this 58Z, right? How do I make a fraction bigger? Now I'm going to go on the side. Please come with me. If I have 1 over 2 and I have 2 over 1, right? Which one is bigger between the two? It's obviously this one, right? Right? It's bigger. And this one is smaller because this will give you a 0.5. And this will give you 2. So which one is bigger? This one is bigger, right? So why am I doing this? Because I'm teaching you fractions. So what does that tell you? It tells you that if I can have a greater denominator, if I can have a positive denominator, then it means that my frequency of the listener will obey this rule, right? I'm sorry about that. It will obey this rule that I set out for myself that says frequency of the listener and all that, right? So let's see. What I'm going to do now is, how do I make this positive? We already have 340 there, right? So since this must be positive, it means now I'm adding, right? I can't make it negative because I want this bigger chapter to be positive, right? Now, what is the velocity of the source, guys? I gave it to you and I said it's 85, right? It's 85. And now we are looking for the velocity of the listener. Now, if the top part, note, if the top is already positive, it means that the bottom it's automatically negative. The signs can never be the same, okay? So you make a decision at the top, and whatever happens at the top, it means it will be the inverse of what's happening at the bottom. So the signs will never be the same, right? So what's going to happen now is that now we are looking for the velocity of the listener. We don't know what the number is, so we leave it as it is. Then we bring back our 50 there, right? Done deal. And then we are looking for what now? They say the frequency of the listener. Do we have FL? Do we have this? Do we have the frequency of the listener? Yes, we have the frequency of the listener. I gave it to you as 25. So I can just easily substitute that right there. Now, from here, guys, it's just pure mathematics, right? It's pure mathematics. What you have to do here is that now what I usually do to save time, okay? Because this is multiplying this side, I usually take this 50 to the other side and then I cross multiply and then I find my VL, okay? So from here, you just go ahead and find your VL as a maths learner, okay? I'm here to teach physics, not mathematics, right? So what I usually do is that I take this and I put it there as a denominator, right? And then what I do, I cross multiply everything and then I find my VL, right? So that's how you do it, guys. That's how you do your Doppler effect, right? So I'm going to create short notes for you to remember so that you can deal with this anyhow, right? All right, guys. So for you guys to pass your test or your examination, I have to do this thing for you guys. So guys, I want you to notice something. The first thing that you have to do is to determine if this velocity of the listener and the velocity of the source. I'm sorry about that. So let's see. Velocity of the source. So the first thing you're going to do, you're going to determine the relationship between these 2 points. Okay, guys? You're going to determine the relationship between these 2 points and find out what is happening. I'm sorry. My pen is malfunctioning. So whatever is happening here. Sorry about that, guys. So first you're going to determine the relationship between this and this. And I already told you how to cram this, okay? If it's coming towards, what happens? If it's going towards, automatically it's like this. If it's going away, what happens now? The FL is going to be like that, right? 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 That's the first thing that I taught you, right? Then, after noticing what is happening there, we have to find a way to make the frequency of the listener or the frequency of the source bigger according to how the question is, okay? So for you to deal with the equation, as I was telling you, is how to make something positive. So if you find out that it's like this, right, that will definitely mean that the source is greater, which means you have to make your numerator negative. Your numerator in the Doppler equation will be negative. But if it's like this, your numerator in the Doppler equation will be positive. Then obviously if the numerator is positive, the denominator will be negative. And this side vice versa as well. If the numerator is negative, the denominator will be positive. Then you start solving. Guys, I hope this makes sense. Unfortunately, I cannot make notes on this, but this is the only way I can explain this for you guys to understand and actually cram this. I hope this tutorial was actually useful for you guys to actually understand what is going on, and this dissection was valuable enough. Okay, guys, I'm going to try and look for other things that might confuse you, but so far it's the Doppler equation. All right, it is always the Doppler equation. So yeah, I think that's it. Please drop any questions that you don't understand on this. I don't mind updating anything that I have missed, or explaining something that I've missed or doesn't make sense. Okay, guys, people might ask you, what is the importance of the Doppler effect? Okay, guys, it's used in a lot of instances, but the most important one is the red shift and the blue shift, where we have to know if a star is approaching, because there is a theory that stars are approaching and stars are moving away from the universe and all that kind of stuff. So we use the Doppler effect to actually determine those. But however, with my experience in looking at the past examination papers, right, you will never, okay, you might, but based on my experience, it's rare to find anything related to blue shift and red shift. What you might usually find is questions related to normal Doppler, but you'll never find that. You only find the red shift and blue shift during the year, June exam and September. All right, guys. So that was it from me, explaining and dissecting the whole Doppler effect thing. And I wish you good luck in your examinations. I hope this was helpful. If it was not, please do comment and I will update the video, which means I will create an updated version of the video, adding on to whatever I was saying. I would really like to make go live someday, you know, solve problems with the learners and everything like that. So if you have challenges, please notify me on the comment section and I will be with you. Okay, guys, thank you very much. Please do not forget to subscribe, guys, right? Please subscribe to my YouTube channel, right? And I have a link of my Facebook page right there, so please like us on Facebook as well, right? Please do not forget to subscribe. I will be teaching a lot of subjects, which include life science, English, maths, and obviously physics. Okay, guys, those are my favorite subjects currently, and that's what I'll be teaching. Not currently, for life. These are my favorite subjects. So I will be helping you guys with all these subjects. So it will be a good idea for you to subscribe for more content, so that you don't miss out on the next tutorial that I'll be dropping. Thank you very much, guys. I hope this was insightful.